Okay guys, this is our 6th video. This video is going to cover mole ratio. So our title of these notes is mole ratio. And this time we're going to be going to different substances. Okay, so previous videos have only covered molar conversions, moles to grams, moles to molecules, moles to liters, and all mixed up of the same substance. So what's different about this video is that now we're going to be talking about different substances. Okay? So, to go between different substances, you need a mole ratio that comes from a balanced equation. I know you thought balancing equations was done. It is not, right? Chemistry never ends. And so now we're going to relate stoichiometry to those balanced equations that we've done in the past. So the coefficients in a balanced equation are the mole ratio numbers. Okay, so for example, let's say we had a really good time burning magnesium, right? So when we put magnesium ribbon and we burned it with oxygen, right? Because anything that's burned is with oxygen. We made some magnesium oxide. So when we balance this equation, I've got 2 oxygens here. So I need 2 oxygens on this side. 2 times 1 is 2, and 2 times 1 is 2. But this 2 changes my magnesiums, so I need 2 magnesiums on that side. So here I have a balanced equation. The question might read, how many moles of magnesium oxide are made from 14 moles of oxygen gas? Okay? So now we're relating different substances. The fact that this is moles and this is moles, they're both moles. Okay? The substance matters. This is moles of oxygen. This is moles of magnesium oxide. So now for every number, you must have a unit, moles, and the substance it relates to, oxygen. But what we do is no different than what we did before. I start with a T-chart. The given goes in the first box, 14 moles of O2. Now my unit needs a substance, because to cancel out moles of O2 come on the bottom. And then what do I want? How many moles of magnesium oxide? So on the top box, moles of magnesium oxide. Okay? So just putting the unit no longer counts. The numbers that go in a mole ratio, see, it's a fraction that has moles on top of moles. Anytime we have moles on top of moles, those numbers come from the coefficients in the balanced equation. What number is in front of oxygen? It's a 1. So the number that goes in front of moles of oxygen is a 1, right? In front of moles of magnesium oxide, there is a 2. So this 2 comes here. This 1 goes there. Okay? And then the math is still the same. In my T-chart, 14 times 2 divided by 1 equals 28 moles of magnesium oxide. Okay? So just slightly different, but the procedure is still the same. Okay? All right. Let's say I have 5 moles of sodium chloride breaks down into sodium and chlorine gas. Chlorine gas can be deadly if you breathe it, right? So my question is going to be, how many moles of chlorine are produced? Okay? So let's start with the given, right? Whenever you get confused, I don't know where to start, Miss Everdays. Start with the given. I am given 5 moles of sodium chloride. Okay? I'm going to need an equation, right? So sodium chloride is going to break down into sodium and chlorine. Chlorine is genuine, so it gets a 2. When I balance this equation, if I have 2 chlorines here, I need 2 chlorines here, but that changes my sodium, so I need a 2 in front of sodium. So I'm going to set up a T-chart. My given 5 moles, I can't just leave it moles now because I'm going to moles. So 5 moles of sodium chloride goes in my first box. To cancel it out, moles of sodium chloride have to go below. And I want moles of chlorine gas. To get my mole ratio numbers, I look at my balanced equation. The number in front of NaCl is a 2. So a 2 must go there. The number in front of chlorine gas is a 1. So a 1 goes there. 5 times 1 is 5. Divided by 2 is 2.5 moles of Cl2. Okay, now I want you to try. So you practice on your worksheet. There's also a link on Canvas if you want to practice there as well. Okay?